Good morning, students. I am R.Dahal, subject teacher of chemistry originally. I am going to teach you the subject chemistry. The chapter is chemical kinetics. In my last class, I discussed about the types of reaction. What we have seen as in our daily life, that in the laboratory, which I told in my last class, there are three types of reaction: instantaneous, slow, moderate, and slow reactions. Now we shall do the next step, that is rate expression and rate constant. Now what is rate? I am going to explain this one by one. You see here, we have taken a reaction, that is reaction AB with the reactant and C and D product, and the small letters, these small letters shows what? These are the molar concentrations. That means A moles of A when reacts with B moles of B produces C moles of C and D moles of D. These are also called stoichiometric coefficient. Now, stoichiometric coefficient of what? A and B are the reactants and C and D are the product. And according to the law of mass action, we know that according to the law of mass action, it is what? The rate of reaction is directly proportional to the molar concentration, as we know. So, directly proportional to the molar concentration. Here, since there are coefficients, so these coefficients will be go here in the as an exponential form, But sometimes it has been seen that here we have given what? However, experimentally it was observed that the rate may or may not be depend upon the concentrations of A and B. That means small a and small b. So it is done what? From where we have to come to know? That we have come to know from experimentally. So if experimentally the rate of reaction is depends upon the term x in lieu of this one, and concentration of A and Y in terms of B. So the in the new form, what will happen? We can write that rate is A to the power x and B to the power y, or rate A B, this one, rate is proportional A to the power x and B to the power y. Now, if when it is proportional symbol, we have to convert to equal, it comes as constant k A to the power x and B to the power y, and this k is called rate constant or velocity constant. That means how the reaction, it has a value, it is a constant. So it is a rate constant or what? Velocity constant. And this we have already know that what? The rate of reaction is directly proportional to the molar concentration. From where we can know? We can know it from the law of mass action. But now from this relation, the definition of law of mass action can be another. The which definition of the law of mass action is another. According to this new definition, what happens? Since there are here it was concentration term is changed, so the definition will also be changed. Now, what will be the definition? According to new definition of law of mass action, the expression in which reaction rate are given in terms of molar concentration. The reaction rates are given in terms of molar concentration of reactant with each term raised to the power which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. That means what? It is given that when we have already know that in experimentally according to law of mass action it should be, but later on it was found that experimentally it may or may not be equal to A and B. So let us take that experimentally it is found that it depends upon not A but in terms x in terms of A and B, x and y in terms of A and B. So experimentally in terms of A and y in terms of B, then the reaction rate of reaction becomes this one. So from this equation, but from this expression, the definition of law of mass action will be changed. Now what will be the definition? that it is defined as what? It is defined as the expression in which the reaction rate are given in terms of molar concentration of the reactants, with each term of raised to the power, which may or may not be equal to A and B. So may or may not be equal to A and B. So it must be, so it is taken as X and Y. So the stoichiometric coefficient and reacting species in the Bernoulli equation. Now we shall go to the next part. See what is from this order of a reaction. Now we shall go to the next part. What? Order of a reaction. We know that order of a reaction. We know that rate is equal to K from the previous from the last one, from that expression. So we have found that K into A to the power X, B to the power Y. So now we have to give what? Order of a reaction. From this, how we shall calculate the order? How its order comes? The sum, this X and Y, the sum of the exponents, the sum of the exponents, that is X and Y are called, but is called, sorry, not are called, is called, exponent is called order of a reaction. It's called order of a reaction. Order of a reaction. So this is the order of a reaction.